Welcome to this new solution video of Probability and Statistics 1. In this question number 1, it is given that x is a variable which has normal distribution with mean 30 and variance 49. So the first number is always the mean, second number is variance. Similarly, y and z are also given as normal distributions. One thing you should notice that the mean of x and y are same, whereas the variance of y and z are same. On a single diagram with the horizontal axis from 0 to 70, so they are giving us a hint that we have to draw a horizontal axis where we write numbers from 0 to 70. So let me do that. Meanwhile, sketch three curves to represent the distribution of x, y, and z. So what they mean is that they want to compare the shapes of these three normal distributions. So if this is 10, this is 20, 30, 40, 50, 60, and 70. Show all the three in same graph. So let's start with the first one. Normal distribution with 30 mean. That means our highest, tallest tower will be here. That means maximum probability is at 30 for x. I'm focusing on x. The mean is 30, but the standard deviation is 7 because standard deviation, which is denoted by a sigma, is square root of variance, and square root of 49 is 7. So we know that the 99.7% of the data is either 3 sigma above or 3 sigma below the given mean. So let's say that it is here. This is the maximum probability here. So 3 times 7, because square root 49 is 7, sigma is 7. So 3 times 7 will be 21. 3 sigma will be 21. So 30 minus 21, which will be 9. That means your graph should finish almost here, 9, at 9. And 30 plus 21 is 51. It should end at 51. And let me try to draw a graph which connects these 3 points. Okay, little above that, but this is the graph for x. I will write it, this is x, graph for x. Let's go to for y. Again, the mean is 30, but standard deviation is square root of 16, which is 4. That means that your data will be 4 times 3. 3 sigma to the left and 3 sigma to the right. 3 times 4 is 12. That means minimum data will be 12 less than 30, which is 18 here, and 12 more than 30, which is 42 here. Since it will be a narrower normal distribution, the mean will be taller. So this is what you need to show in your graph, that this goes taller than the previous one because it is narrower. So every probability will more. The area of whole normal distribution, if we find the area, it is equal to 1. So this area of the narrower one should be equal to the area of the wider one. Let's go to the z. This one is y. Z has a mean at 50. That means our mean will be here. So let me draw it here. Right? Now, standard deviation is again 16 square root, which will be 4 again. That means 12 less than 50 and 12 more than 50. So 12 less than 50 will be 38 and 12 more than 50 will be 62. And it will be exactly a copy of what we have drawn here. This one, the taller one. So it will reach at the same height with same kind of width. This kind of graph. So their heights are equal because the probability of their mean will be same because their standard deviation is same. But the other one will be lower because standard deviation is more, so it will be wider and have the same area. This is what we wanted to show. Next, Question number 2. The people in two towns, Mumbok and Bagville, are classified by age, and this is the table that shows their ages. Alright. The numbers in the thousands living in each town are shown. So that means this is not 15, it is 15,000 actually. And similarly, this will be 35,000, this will be 30,000 and on. One of the towns is chosen. Which one? We don't know. The probability of choosing Mumbok is 0.6. Okay. So probability of choosing Mumbok is 0.6. That means the probability of choosing Bagville will be 0.4 and they've given it. There was no need, but yeah, because these are only two towns, their sum will be 1. Then a person is chosen at random from that town, whichever was chosen, then a person is chosen. Given that the person is chosen between 18 and 60, that means from this particular row, okay, find the probability that the town chosen was Mumbok. Okay, whenever there is a conditional probability question, try to make a tree diagram that will make it easy to understand. So, if I go to Mumbok, if the person was from Mumbok, the probability was 0.6. If the person was from Bagville, this was the probability. Now, if person is from Mumbok, it is possible that the person is under 18 years old. So let me call it U. It is between 18 to 60, let me call it S. And over 60, let me call it O. Under 60, S and O. These are the three. This is under U, this is S, and this is O. Similarly, it will be U, S, and O here. Right? Now, let me write there probabilities. Probability of, in Mumbok, this branch, probability of the person under 18 will be 15 out of, how many are they? 15 plus 55, 70 plus 20, 90. The probability of finding a person under 18 is 15 out of 90. Similarly, probability here will be 55 over 90. I'm not simplifying because I don't want to. Let's keep them simple like this. 20 over 90. Calculations will be easier with this. Okay. Next, similarly here, 35 divided by 130 plus 30, 160. And 95 over 160 and 30 over 160, done. Now the question is, given that the person is chosen from 18 to 60, that means this S group, given that means S will be after given that sign, probability of what are they asking? Given that the person is from 18 to 60, that is S, find the probability that the town chosen is Mumbok. What is M given S? That is the probability they're asking. So the formula for conditional probability is probability of M intersection S divided by probability that it was from Mumbok, right? No, it was 18. Probability of 18 to 60 years old. This is what we will find. Let's find this one first. The branch that shows in our tree diagram, that's why I said tree diagram helps a lot. The branch that shows that the person is from Mumbok and he is between 18 and 60 years old. And Mumbok and 18 and 60, this is the branch they are talking about. So we will find the probability of this branch. So probability of M intersection S, where both of them are happening, is 0.6. First the person should be from Mumbok, and then the probability will be 55 out of 90. We got the numerator. Let's go to denominator. Probability of person being between 18 and 60 years old. So the person could be either this or this, right? In both cases, the person is between 18 and 60 years old. But if I want to reach here, I have to go through, the person should be chosen from Mumbok. If you want to use this particular, which is exactly what we did in PM intersection S. So it will be 0.6 times 55 over 90, which we got in previous part. But it's also possible that the person who is from Bagville and he is between 18 and 60. So 0.4 multiplied by 95 over 160. Either the person was from Lombok or Bagville, and these are the probabilities of him being from 18 years to 60 years old. So we got PS as well. So let's divide them now. PM given S will be PM intersection S is this one, 0.6 times 55 over 90. And PS, probability that person is between 80 and 60, is these two. I'm not solving any one of them. I will just rely on my calculator to solve this for me. In given examples, given questions, you will conditional probability, that is, you will see that one of the numerator is equal to one of them. It's always the same. And that's how you will find it. Just put this in a calculator and you'll get it. By the time I find this with my calculator, I would request you to subscribe to my channel and motivate me to make more such videos. You can demand the solution of any video, any exam past paper from IGCSE or AS level. I will solve them for you. And like and share this video with your friends so that more and more people know about it and they get benefited. Thank you very much. This answer I got from my calculator is 0.60689, and we usually give answer in 3 significant figures, so it will be 0.607. Let's move on to the next one, which is this. Swati measures the length x centimeter of 18 sticks, okay, and found that sigma x square is this, given that the mean length is this, okay. So let me list them down. Sigma x square is 967. Mean length, that mean of original lengths, is 58 over 9. Find the values of sigma x minus 5 and sigma x minus 5 square. Sigma x minus 5 means that the sum of, sigma means sum of the data if 5 is subtracted from each data. And if we want to open this bracket, sigma x minus 5, it is like this. We write sigma x, but after that we don't write sigma 5. Okay, it is something not, we must have a variable here, and there is no 5 is a constant. So in such case, what do? We write 5, but we multiply it by the number of data we have. We had 18 stick insects, so 18. So it becomes sigma x minus 90. That is sigma x minus 5. But they want to find its values, not the expression. That means if we have sigma x somehow, we subtract 90 from it and we'll get sigma x minus 5. So sigma, we know that mean, which is this, is equal to sigma x over n. That is the most common formula. So x is mean of x bar is written as 58 over 9 is equal to sigma x, we want to know, and n we know is 18. So let's cross multiply 18 here. Sigma x is 58 times 18 over 9. 9 and 18 cancel out, it comes out to be 116. So we got it. 116 is sigma x minus 90 equal to 26. We got it. What about sigma x minus 5 squared? Sigma x minus 5 square. It means we subtract 5 from each data, square each outcome, and then add all of them. And it will not be expanded like this. Many of the people, when they are aware of this expansion, they try to expand it this way. I'm doing the wrong thing, please. Don't do it this way. 18 times 5 square. No, this is wrong. We cannot apply the same here. So what will we do? We know that standard deviation is same for both cases, whether it is just x or x minus 5. What I mean is this. Let me write the formula for standard deviation, which is given in your formula sheet. Sigma x square over n minus mean square. Let me write the proper one, which sometimes they write here and people get confused. Sigma x over n whole square. The difference here is that n is not squared, but x is squared inside sigma. Here, first we find the mean. This is basically the mean square. Okay? Is same as sigma x minus 5 square over n minus sigma x minus 5 over n square. Standard deviation does not change even if we add or subtract anything to each data. Even if it was plus 5, it would be same. Right? So, how many of these we know? Just we will substitute. Sigma x squared is 967 and x bar is 58 over 9. Sigma x squared is here 967, n is 18. Let's ignore square root because both sides squared, square roots will go. Minus, this is mean, and mean they have given 58 over 9, and this is the mean of original data, not subtracted data. Okay, when we subtracted 5, the original one was 58 over 9, that's what they gave us, square, equal to, no square root, sigma x minus 5 squared. So we don't know it and we want to find it. So we cannot use the expansion, we have to use this relationship to find that. Again, divide by 18 minus sigma x minus 5 was given to us, it was 100. How much? Sigma x minus 5, we just got it 26. So 26 over 18 again, square. So what is unknown here? Only this one is unknown here. And now I will complete this without explaining. I hope you will understand. $257.022. This is what I got, and if I round it off, 3 significant figures, 257 is sigma x minus 5 square. Question 4. The following are the house prices in thousands of dollars, arranged in ascending order. That is the best part, in ascending order, for 51 houses from a certain area. Why did I say it's a good news? Because for finding the median and upper quartile, lower quartile, for drawing the box and whisker plot, we needed them in ascending order, and it's already done for us. Okay, so for drawing a box and whisker plot, we will draw a horizontal line first, and let's see what is the smallest number here, 253, and the highest is 986. So let's do one thing. Let's start with 200 and end at 1000, so that we have a uniform scale. So they have not suggested a scale, so we will use this way. So okay, so now first thing first, we should start with the minimum value, which is 253. 253 will be between 200 and 300 is 250, so around 250 will be 253 and put a dot at the minimum value. At the same level, straight away here, put a dot at nearly 986, which will be somewhere here. 986 will be here. That is the maximum value. Now we need a median. We have total 51 houses, which is an odd number. Whenever we have an odd number, add 1 and divide by 2 to get the position of the median. 51 plus 2 is 52, divided by 2 is 26. 26 number in this list will be the median. So let me count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 554 is the median. Let's see where is median now. 554 will be somewhere between 500 and 600. So let's put a dot for 554 also. Now, what about upper quartile and lower quartile? For lower quartile, we will find again the median, but of the numbers less than 554. We will not include 554 anymore. Whatever numbers are less than it, we will find their median, and that will give us a lower quartile. So this was 26th. That means there are 25 numbers less than it. 25 is again an odd number. So we will add 1, divide by 2, which is 13th number will be the lower quartile. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 520. 520 will be low quartile, which will be very close to 554 here. And now we're left with upper quartile. Upper quartile will be the median of the upper half after median, 572 onwards. Median of these numbers will be again the upper quartile, and it will be again the 13th number because they are also 25. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 690 is the upper quartile. So 690 is here. So upper quartile, let's write it Q3 because it is usually written as Q3, 690. Lower quartile 1 was 520. Median was 554. In your exams you should list them. So minimum is 253 and maximum is 986. These are the points we have marked here. Now we will do what? First we join the minimum to the lower quartile with a line, horizontal line. Okay. Similarly, maximum with upper quartile with a line. And then we will draw vertical lines at 3 places where we have dots. They will show us the box. This is lower quartile. This is median, almost same height, okay? And this is upper quartile. Join them with horizontal lines to make a box. This is box and whisker plot. Okay, it has more parts. An expensive house is defined as a house which has price that is more than 1.5 times the interquartile range. Okay, let's find IQR first for this question. IQR is Q3 upper quartile minus Q1, which is lower quartile, which is 690 minus 520. 170 is IQR. Okay, so 1.5 times 170. So 170 multiplied by 1.5 will be 255. 255 is the 1.5 times interquartile range above upper quartile. So this is upper quartile. If we get a value which is 255 more than this, that will be called an expensive house. So we know upper quartile is how much? 690. So expensive house will be worth 690 plus 255, which comes out to be 945. Yeah, 945 million, not million, thousands. $1,000. This is the price above which we'll call it an expensive house. From the above data, give the prices of the expensive houses. Which one are more than 945? So we have just two of them, 957 and 986,000. So the answer is 957,000 and 986,000. There are two houses which are expensive. Give one disadvantage of using box and whisker plot rather than a stem and leaf diagram to represent the data. Okay, we have advantages of box and whisker as compared to stem and leaf, but they're saying what are the disadvantage? The only disadvantage I can see here is that the individual data is not visible here. We know this point is here, but it is 986, the detail is not there. So exact data is not with us. So let's say the disadvantage is that specific data is not available. That's the only disadvantage I can see. Otherwise, it has a lot of advantages. Question 5. Length of a certain type of carrot has a normal distribution with mean 14.2. Okay, mean is 14.2. And standard deviation is 3.6. 8% of the carrots are shorter than C centimeters. Find the value of C. Okay, let's try to visualize this. This is our normal distribution curve, and 8%, lower 8% will be from here. This will be 8%. That means this data is C. They're asking us to find the value of C. We know that Z score, that X is less than C, will be C minus mean, which is 14.2, divided by sigma, which is 3.6, right? Problem is we don't know the Z square and C we have to find out. So how can we find Z score? We know this is mean 14.2. This C is definitely lower than 14.2. That means it will have a negative Z score, and we can't get a negative Z score from our table. So what do? We reflect it on the other side and get the positive Z score of a data which is at the same distance from mean as C is on the right side, this one. Okay, now to find this Z score for this one, we need to know the area below this. Since we know this is 8% or the probability is 0.08, the data under this will be 0.92 probability. This is the probability of data below this particular line, 0.92. And from this probability, we can find Z score. And to find Z score, what do we need? We need a table, normal distribution table. And you don't worry, we have the table here. We have to find the Z score for 0.92. We can say 0.91 and 92 is here. 0.9192. To make it 0.92, I need 8 more, so that it becomes 0.9200. So for 0.9192, I have 1.40 Z score, 1.40. Now to get 8, in the same line, I have to reach here, and the line number above that is 6. So we got Z score 1.406 from the probability. That means Z score here is 1.406, but we are not interested in this. We are interested here, which will be negative of 1.406 because it is the reflection of the same Z score on the left side. And that's what we will use here, minus 1.406 equal to C minus 14.2 over 3.6. Let's cross multiply. Minus 1.406 multiplied by 3.6 equal to C minus 14.2. And if I bring this 14.2 to the left side, what does it become? Minus 1.406 multiplied by 3.6 plus 14.2 is C. And if I carry out the calculations, my calculator gives me 9.14. The value of C is 9.14, which makes sense. It is less than 14.2. It is quite less than that. So this is the answer. There's one more part to this. Rebecca picks 7 carrots at random. Okay, so that's her selection. N equal to 7. Find the probability that at least 2 of them, okay, have lengths between 15 and 16. So we will use binomial distribution here. But for binomial distribution, we should have a probability of success. Success, what is success in this case? Success is that the carrots should have a length between 15 and 16 centimeters. And we have our mean at 14.2. 15 will be here and 16 will be somewhere here. And our carrots should have a probability between this and this. That will be our probability of success. So to find that, we'll use normal distribution and then we will use that probability in binomial distribution. All right. So how can I find this shaded area? First, I will find a z-score for 16 and find its probability less than 16. Then I'll find z-score for 15 and probability less than 15. So if I subtract the probability less than 15, which is this blank area, from 16, which will be a bigger area, we'll get the difference, which is this area. Yeah. So let's find the z-score for x being less than 16 first. So it is 16 minus 14.2 over the standard deviation was 3.6, and what I get here is, which is 0.5, and z-score for 15 will be 15 minus 14.2 over 3.6, which will be 0.222. And let's find the respective probabilities for them. First probability, x is less than 16. We will look at this z-score, and for 15 we'll look at this z-score. So let's see, what do we have? So 0.5 z-score is this 0.6915. This is the probability. Let me write it here. 0.6915. Now probability for x is less than 15 will be 0.222 is the z-score, right? So let's go to 0.22, 0.5871, and then we have 2 again, which is 8. So that comes out to be 0.5879. So these are the two probabilities, 0.5879. So to find this shaded area, this one, we will subtract this probability from this probability and we'll get the probability of this shaded area. So probability of x being between 15 and 16 is 0.6915 minus 0.5879, and that comes out to be 0.1036. Now, since we have this probability, this becomes the probability of success we were looking for here. So what does probability of failure become, which is Q? Will be 1 minus 0.1036. If this is success, failure will be 1 minus success. So it will be 0.8964. So we have P with us now, we have Q with us, and now we can use binomial distribution because we have fixed number of selections and we want specific number of selection. How many? At least 2. So at least 2 means probability is x is greater than equal to 2, which means probability of 2, probability of 3, probability of 4, probability of 5, probability of 6, and probability of 7. That means all of them are in this range. Phew, it is such a long list. Why should we do that? Let's do instead 1 minus probability of 0 and probability of 1. These are the two cases which are excluded in this list. Can you see? It is 2, 3, 4, 5, 6, 7. That means before this 1 and 0 are not there. Let's find them and subtract from 1. We'll get this whole list. Right? So let's interpret this in our probability. So probability of x at least 2 becomes 1 minus probability of 0 is n, which is total number of selections, C0. Success is 0, 0.1036 to the power 0, but failures, all 7 are failures. 0.89, what will we get? 64? 8964. That was the probability of failure. 8964 to the power 7 plus 761 success. 0.1036 to the power 1, 0.8964 to the power 6 this time. 1 success, 6 failure. Put this whole thing in a calculator, or you can do this part by part and you'll get your answer. Let me use my own calculator. By the time I use my calculator to find this answer, I would request you to subscribe to my channel, like and share this video with your friends, and let this knowledge spread out. This will benefit all of you and motivate me to make more such quality videos for you. Okay, when I use my calculator, I got the final answer as 0.159 probability. A shop has 7 different mountain bicycles. Okay, different. Okay, they're not same. 7 different. Let's write 7M. M is mountain bicycles. Okay, 5 different racing bicycles and 8 different ordinary bicycles. Okay, a cycling club selects 6 of these 20 bicycles to buy. All right, how many different selections can you make if there must be no more than 3 mountain bicycles? Okay, mountain bicycles, this one, and no more than 2 of each of other 2 types. Okay, so let's write 0, 1, 2, 3. They can have maximum 3 of them. If there are 0 mountain bikes, how many racing and how many ordinary could be there? We have to select 6, so 3 and 3. But they said you can have no more than 2 of them. That means we can't have any situation like this where we have 0 mountain bicycles. So this case is closed. What about this? If 1 is mountain, we need 5 out of them. That means one of them has to be 3 or more. So that means this case is also gone. We are left with only this case and this case. If there are 2 mountain bicycles, how many racing bicycles could be there? At most 2. And there will be 2 ordinary, that makes it 6. All right. 3. And we can have less than 2 also. So this will be 2, 3, 1, 4, and we need 2. Or we can have 3, 2 here and 1 here. And 3, 0, no, if I have 0 here, we'll have 3 on the other side, which is not allowed. So these are the 3 cases we can have, and let's interpret them into selections now. We need 2 mountain bicycles out of 7. So 7C2, we are choosing them, multiplied by 5C2, we are choosing 2 out of 5 racing bicycles, and 8C2, this is one case. Second case would be 7, this which will be this one, okay, 7C3 multiplied by 5C1 and 8C2, and then we'll have 7C3, 5C2 and 8C1. Just evaluate these and you'll get the total number of selections possible. So let's see, 2, 2, 2. If we put this in our calculator, what do we get? We get 5,886 80 selections. 312, we get 4,900 selections, and here it will be 2,800 selections. So only one of these cases will happen. All three will not happen together. When we have choices, either this will happen or this will happen or this will happen, we add them by adding the total number of selections, and the answer I get here is 13,580 selections. Let's see what is next. The cycling club buys 3 mountain bicycles, 3M, 1 racing bicycle, and 2 ordinary bicycles. They bought these, how many? 3 plus 1, 4 plus 2, 6 bicycles. They park them in a cycling rack. What is cycling rack? It is something like this. Remember, we might have seen something like this. We have metallic things, and then you put your wheel in between these two, and then that is called cycling rack, which has a row of 10 empty spaces. Such things are 10. So let's make them 10 spaces. Okay, let's read the question first and then we'll prepare. How many different arrangements are there in the cycle rack? There are 10 total. Mountain bicycles are all together. Okay, so let's put them all together. How many are they? 3 of them. They're all together. That means in that rack, wherever they move together. They're next to each other all the time. The ordinary bicycles are both together. Okay, so these two are together with no spaces between them again, and spaces are all together. So there is 1 racing bicycle which will be alone, and there are some empty spaces which are how many? 3 plus 2, 5 plus 1, 6. Out of 10, 6 are filled up, so 4 empty spaces. And they are also all together. So these are 4 entities which can be rearranged with each other. That means if I want this one will be first, then this 2 will be here, then 4 spaces, and then these 3 mountain bicycles. That means they can interchange their places. Whenever 4 different things can change their places, we call them in 4 factorial ways, right? Now, since these 3 mountain bicycles are moving together, they will join each other and move together, but they can interchange their spaces. There are 3 places where 3 bikes can interchange each other's place because they are different, and because of the different arrangement, we will multiply this by 3 factorial, the spaces they can take within this box. Similarly, these 2 ordinary bicycles, they can also interchange their places. 2 factorial. This can go there. In each case, this can come here. That makes every arrangement is doubled because of these 2. This cannot. This poor guy is alone. So this is okay. Wherever it goes, it's okay. We have already taken care of it in these 4 factorial. When it is changing its place in place of other 3 groups. So now these 4. We should multiply for these 4 by 4 factorial, but we will not. We will not. Why? Because they are empty spaces. They are exactly same thing. If this empty space and this empty space are changing their places, what difference it makes? They are still empty. There's nothing on them. So we will not multiply by 4 factorial because of this. We multiplied by other 2, but not because of this. This will be your answer. So 4 factorial is 24. 3 factorial is 6 times 2, which will be 288 arrangements possible. Number 3, how many different arrangements are there in cycle rack? Again, 10 spaces. If the ordinary bicycle are at each end, so each end of the bicycles, and there are no spaces between any of the bicycles. That means all 6 bicycles are together, and in those 6 spaces, the ordinary, right? Ordinary bicycles, ordinary bicycles are at the ends. So these 2 can interchange their place, so we already have 2 factorial. Now remaining 4, they have not given any arrangement of the remaining 4. That means they can interchange their places with each other. Doesn't matter whether a racing bicycle is between mountain and they are in any order. But they are just four different bicycles, they can be arranged this way. But there are four spaces which are still available, right? How about this? We shift this box by one place. So what will happen? This last space will not be there anymore, and we will have one space on here and three spaces here. What if I move it again? There are two here and two here. This way, there are five places where these six bikes can take, because they have to be together. They said there's no space between any of the bicycles. That means whole of the box with bicycle, it's not actually a box, but a group of bicycles will move together and they can go to five places. Because I showed you there are one place, two place, third itself, four, and five. Five places. So if we multiply them, it will be how much? 2 times 24 times 5. 240 arrangements. Question number 7 and the last. James has a fair coin and a fair tetrahedral die. Tetrahedral means which has four sides. Oh, they've written with four faces. Number 1, 2, 3, 4. He tossed the coin once and the die twice. The random variable x is defined as follows. If the coin shows a head, then x is the sum of the scores of the two throws of die, okay? If the coin shows tail, then x is the score on the first throw. That means there are two situations we have to do. Let's do for head. And probability of getting a head is half. So probability of the table I'm drawing now is half. 1, 2, 3, 4. From first die, 1, 2, 3, 4. From second. This is how we'll get the outcome based on head. So when it's head, we have the sum of the scores. So we will add the scores. 1 plus 1 is 2, 1 plus 2 is 3, and so on. So what I've done, I have added the rows and column. These are the outcomes. But actual score will be from this combination of the scores, this part. There are 16 outcomes possible in this case. Alright, let's go to the other one. If there is a tail, again the probability is half. And what is the case for tail? The first throw is, okay, so 1, 2, 3, 4. These are the only four scores available, and each one, because it's a fair die, probability of each one will be 1/4. Right? Let's move on to the actual question now. Explain why x equal to 1. The outcome is 1. The probability is 1/8. Why? Okay. So we get 1 here. The probability is half times probability of 1 is 1/4. And if I look at the outcomes here in this red rectangle, there is no 1. Now this is the only one where we're getting 1 and the probability is 1/8. They're saying why. They're not saying how. Question is why. So you will write because 1 outcome, yeah, this, okay, 1 outcome, yeah, is not possible with the coin showing head. And with a tail, the probability of x equal to 1 is 1/2 probability of tail multiplied by 1/4 probability of 1, which is 1/8. Let's move on to the second part of the same question. Show that probability of 3 is 3/16. So if I would show you 3 is possible here and here, not this, okay, this is the outcome of one die, this is the combination of the die, this 3 and this 3. So out of 16 there are 2 3s, so the probability of 3 is, first we should get a head, which is half, and then we'll get 2 out of 16 probability of 3. But we can also get a 3 in second outcome, which is half for the tail. First we should get a tail and then we should get a number 3. This will be the probability of 3. So 2 times 1 is, oh, we can cancel this 2 and 2. 1 over 16 plus 1 over 8. So to get same denominator, we'll multiply here. So it will become 1 plus 2, 3 out of 16. So this says show that, right? This says show that, and we have shown it. Okay, we have one more part of this. Copy and complete the probability distribution table for X. So they have already given the ones here, 1, 3, 5, and 7, and 8. We just have to fill 2, 4, and 6. Let's start with 2 and go back to our table. Okay. So what is special about 2 now? Let's see. 2 is only 1 here. This is only 2. That means 1 out of 16. First we should get a half for head and then 1 out of 16 for 2. So let's write here. Probability X equal to 2 will be, first we'll get a head and then we'll get a 2. But we can get a 2 from the second case also. We'll get a tail first and then we'll get a 2, which is half is the probability of tail and 1/4 is the probability of 2. So that comes out to be 1 over 32 plus 1 over 8. So we'll multiply this by 4, 4 over 32, 4 plus 1, 5 over 32. If you have some problem in calculating this way, you can avoid this and just use a calculator. You'll get 5 over 32. All right. Next thing is for 4. So again, we'll go back to our table. We have 4 here 3 times. So 3 over 16 after getting a head. So 1 over 2 probability of X equal to 4 is, first we get a head, then we get a 4, 3 out of 16, and same is for getting a 4 from the second case when it is a tail. So it will be how much? 3 over 32 plus 1 over 8. So to get 32, we'll again multiply by 4. That comes out to 7 out of 32. Alright, third one. Px equal to 6 will be, first we'll get a head and then how many 6's are there in the table? 6's are 3 again. 1, 2, and 3 6's out of 16. So 3 out of 16 is the probability of getting a 6. But there is no probability of getting a 6 in second case. So look, it is 1, 2, 3, and 4. There is no 6. So that's it. That is the only one. 6 over 32. If you want to simplify this, 3 over 16. I could have gotten this 3 over 16 by adding all of them and then subtracting from 1. But I did it individually. It's okay. 5 over 32 for 2. 7 over 32 for 4. And then finally we got 3 out of 32, right? Let me confirm 3 over 32 or 3 over 16. 3 over 16 for this. Now, they all probabilities must add up to 1. Just once you fill them, add them, their sum should be equal to 1. I'm sure their sum will be equal to 1. You just verify yourself. Number 4. Determine whether Q and R are exclusive. Just justify your answer. And what is Q? Q is James throws a tail. Okay. Q is James throws a tail. Okay. then R is value is 7. Okay, so event R is X is equal to 7. What is the question? Determine whether Q and R are exclusive. Exclusive means they can't happen together. Justify your answer. So if two events are exclusive, mutually exclusive, their intersection should be equal to 0. We are aware of the conditional probability that P R given Q. That means score is 7 given that we got a tail is P R intersection Q over probability of getting a tail PQ. So P R intersection Q is equal to probability of Q is half. Now probability of R given the tail is the outcome. That means the score is 7. Okay, is the tail. Can you see a 7 here? No, we don't say 7. So the probability is 0 for 7. So probability of R given Q is 0. So this goes and multiplies here. That gives us PR intersection Q equal to 0, which is the condition for being exclusive. So we can say as the events Q and R can't take place together, the events are mutually, if you want to write the word mutually, it's okay, mutually exclusive because of this thing.